Okay, hi there, Mr. Yates here. I'm just going to be finishing off today the 2018 practice exam, and we're up to question 16, so let's get going on this one. Now, the graph of y equals f of x is shown below, and now just to be clear, that is this parabola right here that I'm highlighting in yellow. And so we've got the graphs of three other things here. We've got one which is y equals negative f of x. We've got y equals f of x plus p, and y equals f of x plus q, where f of x plus p is inside the brackets and q is outside. Now this should be pretty straightforward. The one that is flipped vertically is the negative one. That's what we would expect this one to be down here. And on your thing, you would just make it, so basically what we've got to do for our points is clearly label the remaining graphs with the correct things there. Let's just get that there. So we've got to clearly label the remaining graphs. So there I've got negative f of x, so I just say y equals negative f of x. When we add inside the brackets, we are shifting to the left. So this one here would be our other one there. So that will be y equals f of x plus p inside brackets there. And when we shift up, we are, when we add a number, we are shifting up. So this would be our third one. So it's just really important to make it very clear which one you're looking at, because if you don't make it clear by using arrows or something else like that, then you could easily lose some points for something that you've already worked out properly. So that should be 3 pretty easy marks. Now we have a 1-to-1 relation, y equals 7 take 3x, and we've been given a domain. X can be negative 2, 3, and a, and y can be negative 8, negative 2, and b. So the important thing is here is that these don't necessarily match up to each other. Where x is negative 2, that's not necessarily going to be where y is negative 8. So we've got to try and work out which one maps up to which point. And fortunately, we've got a nice little thing. We've got a nice little equation, y equals 7 take 3x. And in fact, let's make this even easier, because we can use our calculator for this. Y equals 7 take 3x. Now this is only going to be defined at 3 individual points, but let's have a look at what that might look like. And I graph that here. And what I can do is I can actually take these points. When x equals negative 2, what's y going to be? And I look up here, and I've got my line for negative 2, and I can drag up there. When x equals negative 2, y is 13. Easy. When x is 3, what's y going to be? I scroll down. When x is 3, y is negative 2. So we've already got ourselves 2 of our 3 coordinates that are going to be here. And so the other coordinate, we've got to work that out. So when x is negative 2, y is 13. There's no 13 in this one. So that's got to be b. So b has to be equal to 13. When x equals 3, y is negative 2. That does map up to one that we've got there. So the last one, where y is negative 8 is going to be a. So let's have a look where y is negative 8. We go to y equals negative 8, and that corresponds to x equals 5. So x equals 5, y equals negative 8. So a is equal to 5 for that one there. So yeah, that one's not too hard to do, and should be pretty straightforward. So, and obviously there are ways to do this without necessarily using your calculator to sketch a line, but that just makes it a little bit easier to go along with. Okay, next up, the wind speed at a weather station, v meters per second, t hours after recording began can be modeled by this function. Now this is, because we got such a complicated thing here, this is very likely just going to be a can you use the calculator correctly question. So that's what I'm going to write, except instead of v, I'm going to write y. And instead of t, I'm going to write x. So what I've got here is y equals 20 take 5.8x plus 0.75t, or x, sorry, squared, take 0.02 x to the power of 3. And I'll push execute just to make sure that's all good. Now it'll rearrange this obviously so that it's got the on the highest power term on the left. So that's our x cubed, then our x squared, and our x, and then our constant. All of those seem to match up. That looks good. So what I'm going to do is I'm just going to take that, highlight it, drag it down in here. And what's it doing there? It's doing something odd. Oh, there we go. So it seems to have something. Let's cancel that. It's doing something a bit unusual. Why are you doing this to me, calculator? Okay, I'm just going to close that down. Calculator's doing something weird today, so let's just get that back up again. Good thing it's still got it there. So let's try drawing that again. In fact, let's define our range. So according to this, we're sketching the graph over this range. We've got y goes from 0 to 50. Technically they oh yeah, no, that's v. So 0 to 50. And let's put in a scale of 5. That should match up to these little divisions here. Actually, if I do 10, then it'll do more lines there. I'll do it at 10. And then the x is going to be from 0 to 24. And that looks like a scale of 1 there. So let's see how that looks. There we go. And that should be the same one we've got there. And so let's drag that in there. There we go. Okay, so now the thing that it was asking for up here was to calculate this with the wind speed when t equals 11. I can do that. We're calculating y. So when x equals 11, that's what y is going to be. And y is 20.33. Well, we don't want to write y. We want to write v equals 20.33. And we want to use the units that we've got there. Let's see, meters per second. So we want to say meters per second up there, just to make it clear that we're doing the right thing. So 20.33 meters per second. Let's just clean up that 3. And if we sketch this, we know a point already. We know 11 and 20.33. So we know a point there. And let's try and find a few other points. So we want to find our maximum. That's going to be 20.21 and 44. And you should always write in the actual points that we've got here. So this is going to be 11, 20.33. And we want to find our minimum. It's worth taking a bit of extra time to do this because it is worth quite a few marks. So that's 4.78 and 7.22. There we are. And we want to, let's just find the Y-intercept as well. Obviously that's going to be 20. So I can sketch this graph. It's going to go through there, and we don't need to be perfect with our sketch. We just need to go sort of down there, make sure we go through all these 3 points, and it'll always help to find our endpoint. So I'm going to do gsolve a ycalc for when x is equal to 24. Oh, what's it doing now? It's doing this again. Let's cancel that and see if it's still doing something funny. There we are, 36.32. So if we've got a few points, we can sketch that out. Don't need to be perfect with it all, but probably at least one decimal point would be a good one to go for these. And it is worth 4 marks, so it is worth spending a bit of extra time to get these, because it's not too hard to do. And it can help you out with this others. So at what time was the wind speed the greatest? That was at 20.21. And let's look back at the original question. It says it's, where are we? So v meters per second, t hours after recording began. So it's going to be 20.21 hours. And it may have said it started at a time, at which point you would have to have said, oh yeah, that would be at, let's say it was 8 whatever, and you multiply the 0.21 by 60 to get how many decimal points that was. What was the minimum wind speed? The minimum wind speed, we've already got that, 7.22 meters per second. The length of time that the wind speed was increasing, we've got that as well because we've just done all this work on here. So we can get those values out pretty quickly. So it was increasing from the minimum to the maximum. So we have this maximum value here at 20.21 and then 4.78. 20.21 take 4.78. And we work that out. That's 15.43. And we do 0.43 times 60 because we want the length of time in hours and minutes. And that's 25.8, so we're going to call it 26 minutes. So that's going to be 15 hours and 26 minutes that the wind speed was increasing for. So yeah, that should, and basically even though I spent a little bit of extra time doing this graph, it meant that I was really easily able to answer these questions down here because I labeled all these points. I didn't have to recalculate these ones. And even if I got this wrong for whatever reason, any teacher would reasonably give you these follow-through marks for doing those all correctly. So that should be good for that one. Okay. Next one up here, question 18. We've got a cubic, and it's a cubic that is just our standard cubic, which looks like this. So our standard cubic looks a little like that, except a few things have been done to it. It's been shifted to the right, it's been shifted up, and it's been flipped upside down. So we've got to remember that when we're having a look at this particular cubic. So what have we got? We've got negative 2 brackets x minus b all cubed plus c. B and c are constants. Now, the degree of f of x, that is going to be to what power are we looking at our highest term. Now, when we expand all this out, our highest term is going to be negative 2x to the power of 3. That's going to be our highest term. So the degree is 3, because that's just based entirely on the power of that number there. So the degree is 3. What's b? Well, it's been shifted to the right 4 spots, so b equals 4. Easy. What's f of 0? Well, we need to know what c is. It's just been shifted up. This is the sort of focus point, or saddle point, point of inflection, whatever you want to call it. This point here has been shifted to the right by 4, up by 2. So we know that b is 4 and c is 2. And at the y-intercept, x is 0. So what I'm going to do is I'm just going to throw this in my calculator. But it's going to be negative 2 times negative 4 to the power of 3 plus 2. But there's no reason to try and make this hard on ourselves. -2, -4 to the power of 3 plus 2. We've got a calculator, we can use it. 155.8. That doesn't seem right. I had an answer in there that I don't need. -2, there we are. 130. There we go. Remember to always do your little sanity checks. If something doesn't quite seem right, it's probably not. So just double check that you've entered the right thing. So in here, I accidentally put an answer in there because I pushed this subtract instead of this minus, or the subtract symbol instead of the minus symbol, which is a different one on the class pad. So that's what we've got there. Yeah, that's all there is to that one. That's pretty straightforward. So another function is given by g of x equals f of x plus 8. How do we obtain g of x from f of x? When we add 8 inside the brackets, we're really just doing a translate to the left by 8 units. Now this is the easiest 2 marks you're probably going to get. It's really easy, just 2 marks right there just for saying translate to the left by 8 units. You can get these marks in less than 5 seconds, or about 10 seconds or so, just to write that out. So yeah, that's some easy marks there. Question 19. During 2018, the altitude of the sun, theta degrees at noon, can be modeled by this equation. Okay, this is going to be another can you use the calculator question. Let's have a look. On the 26th of January, the altitude was that. Calculate the altitude 10 days earlier. So it's going to be the nth day of the year. So we know that n is going to be 16. So let's try that. And I'm going to do y equals 23.5 sine brackets, and let's turn this into a proper thing here. 8 pi times 101 plus x, because x is going to be n for this one, over 1461. This all seems like a very complicated equation, but we'll see what it ends up looking like. So there's my equation, and what I'm going to do is I'm just going to replace that with 16 temporarily. So n is 16, theta is 53.03 degrees. So yeah, now, does that make sense? No, it doesn't really make a lot of sense to me because I wouldn't have imagined it would change that much. Let's have another look at here, see if I've made a mistake. 8 pi 101 plus 16 plus 52, oops, 52.2. And let's see if that does the right thing for 26. If I write 26 in there, does it give me the right answer? No, it seems to give me a different one. So 26th of January, the altitude was 71.4 degrees. Now, why is this giving me a different number? Ah, there we are. So it needs to be in radians. So because I should have been doing this in radians already. Because we had pi in here. When we got pi in there, that indicates we need to do radians, even though it is asking for degrees in there. So this is a little bit of a trick question. So I wasn't getting a number that was close enough to my 71.4 there. And that made me realize that I needed to make sure I was doing degrees instead of, or radians in here, even though here it says we're measuring in degrees. So that's a little bit confusing. So that's wrong. And it needs to be 73.44 degrees. There we are. Because when you think about it, we expect the altitude of the sun to not change that much 10 days earlier. So this is really definitely a sanity check question. This is checking, are you noticing whether or not the right or wrong thing is being done here? So then we want to graph that. And let's just make sure we've got our range proper. X is going to go from 0 to 400. And it looks like we've got 25, or we'll do 50 as a scale. And we've got 0 to 80. And we've got 10 as a scale here. And we've still got that other graph in there, but let's try and get this one in here. Okay, now it needs to be degrees or radians. What do we got here? Let's just clear this. Let's do that again. So the range is from 0 to 400. We'll put 50 in there, and then the Y is from 0 to 80, and we'll put 10 in there. Now this one is in, we want this to be in radians because this one was in radians. So, oh wait, yeah, that's right. We didn't put our N back in there. So we've got to put X back in there. Let's select this again. Like that in there. Yep, that's a bit more like what we expect it to look like. Okay, that's looking good. So when we're graphing it, we want to find our starting point. Our starting point is going to be 52.2. Or will it? Let's find out. It might be, but it might not be. So the Y-intercept is at, it says 75.37. So we're going to write that up here, 75.37. That's where we are there. Let's see where the maximum is. We have a maximum at 355 and 75.7. $355.56, 75.7. So those are our coordinates there. And let's try and find the minimum. The minimum is going to be at 172.94 and 28.7. Doesn't need to be perfect. But that's what we've got there. So it looks like that this goes down, passes through there, goes up there, and then goes down again. Now it doesn't need to be perfect. It just needs to be roughly okay. So what's the minimum altitude of the sun at noon in Melbourne, and on which day of the year did this occur? So the minimum altitude is 28.7 degrees, and that was at 172.94 days. Let's round that up to 173 days. Now this may take a little bit, but we can do 31, oops, not 30, now it's 2018 this one was, so there's going to be 28 days. And 31, 30 days, oh, that's January, February, March, April, May, June, it has 30. July, 30 days of September, April, June, and November. So there we go. So let's do 173, and we'll go subtract 31, 28, 31, 30, 31. This is a lot of work for just one mark. Let's see. Okay, we've got 22 after that. So it's going to be, there's 22 days after the 31st of May. So it's going to end up being the 22nd of June. So that does end up being a little bit of work for 2 marks, but we can work it out. Just got to be a bit methodical about it. So solar panels on the roof of a Melbourne business are designed to meet its entire power needs on cloudless days when the sun is at least 36 degrees at noon. Draw a straight line to represent this requirement. So it's going to be 36 degrees at noon. So that's basically this line here. If it's above that line, it's all good. Determine the number of days the panels are expected to achieve this, ignoring the possibility of cloud cover. So what we want to do is we want to do an analysis, gsolve. We're finding when what our x value is going to be when our y value is 36. So that's going to be 100, and let's just get a little bit further down. That's going to be 125.84. And the other one is 220.03. So let's subtract those. So 125.84. I'll do the subtract. 220.03. And that's 94 days. So we want to do 365, take 94 to find out what's left over. Um, 271 days. Hopefully that's right. But the methodology is there. Now this was a bit of a tough one. And sort of having to deal with the fact that we're looking at days and having to try and work out what months we got and things like that. That can definitely try and trip you up there. Okay, next up. Now we've done this one in class, but I'll do it again quickly. So we've got the coordinates P, Q, R, and S. A thing to remember is that R is negative. This is a negative number, the coordinate of R. That's going to become relative. That's going to become relevant a bit later on. So what would tan theta be? Quite obvious. It's sine theta over cos theta, or it was also the gradient. So we will really just call that Q over P, because Q is sine theta, P is cos theta, or rise over run is Q over P. So what's sine of 180 take theta? That's going to be the angle going up there, like that. It's still going to be the same one, but so Q is still going to be Q over this side. P hasn't changed, so it's still going to be Q over there. Cosine of y, or cosine of gamma rather. Remember that cosine of gamma actually comes up here. Cosine is the x coordinate, but remember this is a negative number, so R1 over here is going to be positive, which means we need to do negative R to end up turning it into a positive number. Sine of pi plus gamma, that is going to be sine of pi, it's going to go pi is 180 degrees, and then plus gamma, so that's going to be this angle down here. And that means that S, our y coordinate, is going to be negative. So sine of pi plus gamma is going to be negative S. Cos of gamma take theta. Gamma take theta. So this one is just a hint here, is it's worth 3 marks. So it's going to be a little bit more involved. And what it's actually going to involve is it's going to involve our cos identity. Cos, that's going to be gamma cos theta, if you know your identities. And it's going to be plus sine gamma sine theta. You can put the brackets in there or not. I'll just put them in there for the time being. Now we've worked out all of these. That's negative R. Cos theta, did we work that out yet? No, cos theta is just going to be P. And then sine gamma was S. And sine theta was Q. RP plus SQ. And you don't need to necessarily do them in alphabetical order, but if you really wanted to, you could do negative PR plus QS. but I give you full marks for that either way. And that's what we're doing. We're just identifying the double angle formula, pulling the right numbers out of here. And if we've already been careful about this, it shouldn't be too hard to do that anyway. And there we go. So now this looks like the last question here. And this is, again, a can you use your calculator question. What is the exact value of cos 36? Cos 36, oops, where are we? Cos 36, make sure my calculator is in degrees. And we want the exact value, so it's not enough to just do, let's close this one off as well, because that's annoying me a little. So it's not enough to just do that, I gotta work out the exact thing. Cos 36 is root 5 plus 1 over 4. What's the exact value of sine 105? Sine 105. That is root 2, root 3 plus 1 all over 4. So this one, solving that for the range that we've given there, this is absolutely a can you use your calculator question, because what we want to do is cos of x plus 60, make sure we're still in degrees, equals sine x. And we want to do a range. So we go up to keyboard, it's under math 3, and we do a vertical line. That means for negative 270, so given that x is between negative 270 and 270, you are not expected to work this out without doing this. Now we're going to be solving, so I'll put a solve at the front. And it does give us an answer. It gives us an answer you could never work out on your own, but we just got to write that one out. So that's going to be 2 tan to the negative 1. And we're going to need to write out all of them. 1 over root 6 plus root 3 plus root 2 plus 2. Take 1. 180 rather. There we are. What's the next one? It is 2 tan to the negative 1, root 6, root 3, root 2, 2 on the bottom. So it's plus 180 there. So I'm just going to put a plus or minus 180. So I don't have to write that out again. This is the last question of the test, so we may be pressed for time. So x equals that, or it's going to be 2 tan to the negative 1, root 6, take root 3, plus root 2, take 2. So it's a bit complicated writing that all out, but it's 2 marks for basically showing that you can use your calculator. So using suitable exact values of acute angles, this is 5 marks. This is a lot of marks for a not very difficult question if you know your angle sum formulas. How can we justify sine 105? If you recognize that sine 105 is actually sine of 60 degrees plus 45 degrees, that's sine 105. And we know sine 60, we know how we can redo this. That's going to be sine 60 cos 45. And then it's going to be plus cos 60 sine 45. Now we should know all these values. Sine 60 is root 3 on 2. Cos 45 is root 2 on 2, or 1 on root 2, but I recommend using this version of it. Cos 60 is a half. Sine 45 is root 2 on 2 again. Now, we've got root 2 in both of those, so I'm actually going to take root 2 as a factor out the front. And then we've got 2 times 2 on the bottom, the 4 at the bottom for both of those. And as we can see, that is exactly what we've got up there. If you didn't happen to take the root 2 out, you would need to be able to show that it was that exact same thing. Or you could just do that. Now, a rule of thumb, if you get stuck and you think you've done the right thing. So let's say you didn't know that, and what you did was you just did, okay, root 3 times root 2 is root 6. That's over 4. There's root 2 over there. And you got there and you think, oh, I think I'm there. Am I there? What you can do is you can just write the final thing in. So you can just write, okay, I don't know exactly how to simplify it, but I'm just going to write root 2, root 3 plus 1 on 4, and then write QED. So even if I'm not exactly sure how to do that, this can be a way to sneak yourself an extra mark or two. And I can't tell, and the teacher can't tell the difference when they're marking it. But either way, that's just a way to snag yourself an extra mark. If you think you're close, but you can't work out exactly how you're supposed to do it, just say the thing you're supposed to prove and write QED. Mathematicians do that all the time, trust me. Anyway, so that's the end of the exam. Anyway, I hope that was useful for you. And these exams will also be available on the Connect page, so you can have a look at these and look over these videos and just sort of make sure you know what you're doing. And good luck for your exams. Have a good one.